Good evening, dear colleagues. Speaking from Gaeta, a little city set on a promontory stretching towards the homonymous Gulf, overlooking the Mediterranean Sea in the center south of Italy, right between Rome and Naples. Since ancient times, my hometown has been famous for its lovely and temperate climate. Indeed, its original Greek name also meant cave, as it historically served as a harbor. The city is placed on average 2 meters above the sea level. Being located in a bay and protected by a mountain range just behind it, its territory is relatively safe, not frequently hit by heavy weather events. Notwithstanding this, three interwoven phenomena affect this area to a meaningful degree: floods, landslides, and fires. Here, I want to focus on the first one. Gaeta is part of a recent trend towards heavier precipitations, which characterizes the whole country. Last year, we witnessed a flash flood, making streams outflow and the sea level rise to flood part of the historic town center, causing damages to property and also killing one person here in my hometown. The mapping process of flood risk across central southern Italy is still underway, as the country lagged behind the implementation of European Directive 2000 number 60 of the European Union concerning regional plans for flood risk management. The widespread opinion among Italian climate scientists is that human activity is directly involved in this process, with its most visible manifestation being increased urbanization and population density, deforestation, illegal building, and lack of maintenance of waterways. The other protagonist in this plot is rain. On this point, we can reason about a more indirect human influence by anthropogenic climate change. Scientists argue that floods have happened in the past, but notably today we observe an increase in the frequency and in the intensity of these events, especially during autumn and winter across the Mediterranean region. Indeed, on a broad level, scientists recognize that increasing surface flooding is a very likely direct consequence of climate change, as the design standards for stormwater drainage systems is based on a commonly occurring rain event, typically 1 in 30-year return period. Systems built to this standard will not be able to cope with the more extreme high-intensity short-duration storms. With an increase in storminess predicted, we can therefore expect more surface water flooding in our region, and in this constitutes a dilemma for flood risk mapping and policymakers. I conclude that such challenges require an integrated approach instead of isolated public policies and public funding. Key challenges are to achieve good status of the water and stakeholders' involvement. Integrated approach includes balanced management of vegetation cover, water and soil resources, and physical area adaptation of landscape profile in water basins.